Welcome to math class. We are continuing on in the Math Makes Sense 9 textbook. We are working on section 4.3, and what they're looking at is we're still dealing with linear relations, but we're particularly working on what I like to call equation skills. And if we're given an equation, we can follow mathematical principles and actually start manipulating a lot of that stuff around. So what we're going to be looking at is the example on page 176, on the bottom of page 176. They've given us a handful of very simple equations, and they want us to figure out how do we take an equation like that and put it onto an XY coordinate plane. But what we actually have to deal with here first is, okay, sorry, I just had to put my coordinate plane back on my screen. So what we actually have to deal with here first, let me move this as well, is looking at what happens if we have an equation where we've only got one variable. Now, these are actually pretty easy. What this means is that we either have a vertical or horizontal line, depending on whether or not this is an x-axis or a y-axis. So for instance, if I look at x equals -4, what I have here is I have to count along my x-plane. I count backwards 4. 1, 2, 3, 4. I don't have any y value, so what that means is that this is actually a vertical line, change my color too, that goes all the way from the bottom to the top. Oop, let me get rid of that. Delete this. So it actually moves from the bottom to the top all on one line. Or what it's also referred to is a vertical line that intersects, so it crosses the x-axis at -4. Right? So what they're saying is there's a vertical line and it crosses the x-axis at -4. All right, so that's what it means if you ever get an equation where you have just the x or the y and it equals a singular number. It means we've got a single straight line that goes up or down our vertical or horizontal plane. Let's take a look at our next example where we actually, oops, went too far. Okay, we actually have a y value that we're going to sort out, and we get to start looking at the equations that we are able to manipulate. So just like fractions, right? Anytime we are dealing with an equation, I have two distinct halves of the equation. Now, anything I do to this side, I also have to do to this side, and vice versa, right? So I can go ahead and get real crazy, and I can just start chucking numbers around in here. So let's say I'm going to get crazy. Just for fun, I'm going to add plus 10 to this side. I'm also going to add plus 10 to this side. So now I get y plus 12 equals 10. As long as I did the same action on both sides, this is not changed. The numbers have changed, but the answers are still going to be the same. Mr. Waldo, what does that mean? Why are you doing that? Well, apparently I did my circle trick wrong. The reason we need to know that is because if we have situations like this, where I have a variable and a number on one side and 0 on the other, I need to isolate my variable, which means that I need my variable to be y equals with a whole bunch of other stuff over here. Go on forever and ever and ever as long as we care. But what I need to have is that y, or the x if you need to, all by itself on one side of the equal sign. Get rid of that and that. So what do we have to do here? Well, I have a y plus 2 equals 0. I need to isolate that y. So what I'm going to do is get rid of this plus 2. The way I'm going to do it is by doing the opposite. So I'm going to minus 2 over here. Whatever I do to this side of the equation, I also have to do over here. So I'm also going to minus 2 over here. What that means is now I have y plus 2 minus 2 equals 0 minus 2. Plus 2 minus 2 equals 0. 0 minus 2 equals negative 2. Now I have y equals negative 2. Just like the last equation, anytime I have a single variable that equals a number, I'm going to have a perfectly straight line. My x was the, oh, I forgot to put my y here. Ooh, horizontal. My x is my vertical lines, and I know therefore that my y is going to be a vertical line that intersects at negative 2. Right, so I can go in here, take my green line again, and I can draw a line straight through to negative 2. All right, let's look at a slightly more complicated example of the same thing. I'm just going to give myself some more room to work with first. Okay. Oops. Let me get rid of all this stuff. Oop, this is over here. These will be deleted. All right, we have 2x equals 5. Oh, look at that one too. So what I'm going to do here, let me get a coordinate plane to work with. So 2x equals 5. I still need to do the same steps. Let me get this stuff out of the way. I need to get this x all by itself. So I need an x equals yada 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 statement. In order to do that, I need to do the opposite operation of whatever is going on with my number. So right here, 2x is the same as 2 times x, which is also the same times x, which is also the same as x times 2. All right, so what we're going to do is we're going to do the opposite of multiplication, which happens to be division. So I'm actually going to divide both sides of my equation by 2. What happens here, my 2's over here cancel, or they don't really cancel. What actually happens is I have 2 divided by 2 times x equals 5. Well, 2 divided by 2 is the same as 1 times x equals 5. Well, I'm sorry, over 2. 1 times x is the same as x equals 5 over 2. So they don't really cancel, but effectively, once we divide it by 2, we have gotten rid of that 2. Okay, sorry about that, a little interruption. So I know that x equals 5 divided by 2. I don't even need to pull a calculator out for that one. I know that x equals 2.5. I also know from my previous questions that whenever I have an equation with only one variable equaling a distinct number, I'm going to have a nice straight easy line to work with. My line is going to intercept the x-axis at 2.5. So I count here, I go 1, 2, and 0.5. I'm going to take my straight line, let's make it blue to keep it easy, and I'm going to go ahead and draw my straight line right through the middle of 2.5. So that is what we do. That's a little bit of a primer on how we manipulate equations, as well as what do we do whenever we have an x equals or y equals number statement. Now, let's go ahead, oh, let me stop doing that maybe. Let's go ahead and look at the slightly more complicated version of the same thing, where I have to get used to substituting variables and manipulating that equation. Oop, wrong slider bar. Ooh, where we go? Oh yes, it's hiding over here. So that's not what I wanted. Page 177, we're going to be substituting variables and manipulating the equation. So let's take a look at it. Do you give us the equation of 3x minus 2y equals 6? So we have to look at a couple skills here. We have to substitute, and we are going to be manipulating. Okay, we're doing a little bit of both. So what they want us to do is, first up, A, is make a table of values. Remember we did this last time? Actually, you know what? I'm going to go ahead and copy my coordinate plane again. Delete. We are going to do A, but I'm going to go ahead and steal one of these bad boys and drag it down. Okay. All right, so we have our XY value table, right? So what they're saying is, I'm going to move this over here. What they're saying is they need us to figure out what the table values is when x equals -4, 0, and 4. All right, so what we're going to do is we are going to go ahead and substitute that into our equation here. So I'm going to do it one at a time. I'm going to do -4 first. So I'm going to go 3 times -4. So all I do is put the number in place of the x, minus 2y equals 6. So my writing's a little bit big here. So 3 times -4 gives me -12 minus 2y equals 6. I need to get this y by itself. So I'm going to try to get rid of this 12 and this 2 here. First way I'm going to do this, the opposite of -12 is +12. So I'm going to add 12 to both sides. So now I get -2y equals 18. Still need to isolate this y. So I'm going to go ahead and divide this by -2, divide this by -2. So, as we talked about, those cancel. I get y equals -9. So I'm going to go ahead, bring this back up to my xy table. When x is -4, y is -9. And now I'm going to go start the whole process again, but with 0 in place of the x. Let me get a bigger eraser. There we go. So I do 3 times 0 minus 2y equals 6. 0 minus 2y equals 6. -2y equals 6. So I'm going to go ahead and divide by -2 on both sides. Y equals -3. So I go back up to my equation. When x equals 0, y is -3. One more left. Punch it in for our very last turn here. And I'm going to go 3 times 4 minus 2y equals 6. I get 12 minus 2y equals 6. Now remember, this is where our manipulating equation skills comes in. I need to isolate this y. So what I have to do is a whole bunch of opposite equations. So for instance, this is positive 12. I need to get rid of it. So I'm going to minus 12 away from it. Whatever I do to one side, I have to do to the other. So now over here I have 6 minus 12. So now I get 12 minus 12 minus 2y equals 6 minus 12. I can go ahead and simplify that down. 12 minus 12 is 0. So I get -2y equals -6. I divide by -2. I divide by -2. Y equals 3. So when x equals 4 on this particular scale, y equals 3. So my next step is to then go ahead and plot this on my graph. So starting with my first point, I have 1, 2, 3, 4 to the negative. 1, 2, 3, 4, 5, 6, 7, 8, 9 also to the negative. My first point is going to be right there. Once again, remember, I'm only drawing those lines in so that you guys have an idea of what to follow while you're watching the video. Sorry. You shouldn't be drawing those in. Or at least if you're going to draw them in, you should do what I'm doing and erase them after as well. So my next point, I now have 0 on the x-axis, and I have -3. So 0, and I'm going to count down 3. 1, 2, 3. My next point on the line is right there. My last point, I'm going positive 4. 1, 2, 3, 4. Then I'm going up 3. 1, 2, 3. And my final point is right here. Once again, I'm going in to erase these counting steps. And then all I have to do is go ahead and draw my line. Let's do another green one. I draw my line right through all 3 points. I can even move it around a little bit if I need to. And there is my linear relation. All right, those are the skills we're working on today. I will see you in math class.